speaker will be Mr. Tetsuya Wakabayashi, and the title of this paper will be Recent Technology for Vascular MR. Then please start.
Hi, I'm Tetsuya Wakayama from GE Healthcare. I'd like to talk about our recent technology for vascular MR. It's a disclaimer that some of the slides I will present today include the technologies in development, and not all of the contents are available on our current product. The first topic is the Aircon DL. So we have provided Aircon DL in our product application, which is our deep learning-based reconstruction compatible with all anatomies and also available on all our systems. The right side shows the images with Aircon DL. So our Aircon DL can improve the SNR and the image sharpness, and also reduce the truncation artifact. So you can see the better images by the Aircon DL compared to the conventional reconstruction. So in the next slides, I'd like to show some the vascular-related images with Aircon DL. The first one is the Aircon DL with 3D heart for coronary artery MRA. The Aircon DL improved the SNR of the coronary MRA source images, so which could help the better conspicuity of the coronary arteries. And the next one is the Aircon DL with the enhanced inflow IR for the non-contrast enhanced renal MRA. Similarly with the previous slide, the Aircon DL improved the SNR and the image sharpness of the source renal MRA images, which could also help the better depiction of the renal arteries, as shown here. The next one is the Aircon DL for the MSD-EQ, which is our application for the intracranial vessel wall imaging. So our cube is basically a 3D FSC sequence, and some techniques such as hypersense, hypercube, and adiabatic spec IR fat suppression are compatible with the MSD-EQ. And as you know, that intracranial vessel wall imaging typically requires a very high resolution imaging, and in that case, the SNR can be easily a problem for that high resolution protocol. But as you can see on the right side, so that our Aircon DL can significantly improve the SNR of the images. Now this is the 0.5 millimeter isotropic intracranial vessel wall imaging. So this slide shows the MSD-EQ vessel wall imaging and also the 3D TOF MRA with the same voxel size of the 0.5 millimeter isotropic spatial resolution. As you know, the one benefit of the high resolution isotropic imaging is that we can see the good curved reformat aligned with the intracranial vessels, as shown on the right side. And also the high resolution imaging also gives the depiction of the very small vessels such as the perforating arteries, as shown in this slide. So with the high resolution protocol, so we can identify the perforating arteries both on the MSD-EQ vessel wall images as well as the 3D TOF MRA. So this is a slide for our technology development. As I mentioned earlier, that the high resolution imaging typically suffers from the SNR of the images. So now we are developing the Aircon DL for 3D TOF MRA. And as you can see on the slide left side, the Aircon DL can improve the SNR of the 3D TOF source images significantly, which can also help help provide a good MRI MIP images shown on the right side. And this is the MRI MIP images in the 3 different planes. As you can see, we could obtain the good MRI MIP images with any direction using the Airicon DL. And the next slide is not related to our Airicon DL technology, but I'd like to share about this application named Flexa for fast non-contrast enhanced carotid MRA, which is also our technology in development. So the Flexa is basically multi-slab 2.6 imaging with some optimization for the carotid MRA. So as you know, the carotid MRA is often difficult to get a good image quality with using the 3D ToF. But as you can see in the slide, so our Flexa can provide better MRA images compared to the 3D ToF with the much shorter scan time. Yes, let's move on to the next topic, the Sonic DL, which is our new deep learning-based reconstruction, different from the Airicon DL. So the Sonic DL is a deep learning-based reconstruction techniques focusing on the speed of the imaging. So as you can see on the right side, the conventional approach with the parallel imaging techniques typically requires a significant number of the heartbeats to collect the data for one slice, but with the Sonic DL, we can collect the image with less heartbeats compared to the conventional approaches. Our Sonic DL allows a much higher acceleration factor compared to the parallel imaging. The middle image is the Sonic DL with the 3 heartbeats per slice acquisition, and the right image is the Sonic DL with a single heartbeat. So which means the 1-bit cine imaging can be available with our Sonic DL. So our Sonic DL is applied to the highly undersampled data in the KT domain. And we use the coil sensitivity map to retain the data consistency, and our Sonic DL deep learning network synthesizes undersampled KT data to make the final good cine images. And also the Sonic DL can be applied to the breath hold acquisition and also the free breathing acquisition. In the breath hold example shown on the left side, the Sonic DL allows the cine imaging with the 3 heartbeats per slice, while the conventional technique requires a 10 heartbeats per slice for the similar acquisition. So which means our Sonic DL can reduce the total number of the breath hold time in the whole heart cine imaging. On the right side, the Sonic DL also can be used with the respiratory triggered scan. So if you prescribe the very high acceleration, so you can get the single heartbeat cine imaging shown on the right side. So the Sonic DL allows you the cine imaging with a very flexible protocol depending on the patient condition. So if the patient can hold the breath in short time, you can prescribe the short breath hold cine imaging, as shown on the left side. And if the patient cannot hold the breath, so you can prescribe the respiratory triggered cine imaging. And also if the patient has a severe arrhythmia, then you can prescribe the single heartbeat cine imaging with a Sonic DL. And also if you need a high resolution cine imaging, you can prescribe the respiratory triggered high resolution protocol. So the next slide is the the how sonic DL can be used for also the aortic cine imaging. The main purpose of the sonic DL is for the cardiac cine imaging, but we can see the aortic cine images with sonic DL as shown in this slide, and which will be useful for the quick observation of the magnitude-based aortic cine flow. So you can see the good magnitude-based cine flow in the descending aorta with a large FOV. So of course, if you want to make more quantitative evaluation, you can use the 4D flow acquisition. So we provide the 4D flow acquisition shown here. One highlight technique of our 4D flow is a unique acceleration technique called the hypercut, which gives you a higher acceleration factor in KT domain up to the 8-fold acceleration factor. Yes, let's move on to my final topic, the vascular imaging and 70 ultra high field. The first slide is the high resolution 3D TOF on 70 system. So basically the T1 relaxation time is longer at 70 compared to the 3T or the 1.5T system, which means that we can obtain the better background suppression and also the good inflow effect on the 70, which is more beneficial compared to the 3T or 1.5T system. So that's why we can obtain the good TOF MRA images on the 70 system. Next is the high resolution SWAN, which is the susceptibility weighted angiography on 70 system. So it's believed that the SWAN partial minimum intensity projection shows a small venous structure due to the venous susceptibility effect. So that the sensitivity of the susceptibility effect is relatively high on the high field strength. So the SWAN on 70 system could provide a very nice depiction of the small venous vasculature in the intracranial region. The next slide is the MP range, which can be used for both the T1 weighted image and also the MRA images. So as you know, the MP range on the 3T or 1.5T whole body clinical scanner system, the blood signal is typically low, but on 70 systems, we use the local transmit coil for the local excitation, which means that we can reserve the fresh inflow effect. That's why we see the very high blood signal on the 70 MP range images. So which means that we can obtain the simultaneous acquisition of the T1 weighted images as well as the MRA MIP images. But it can be a advantage, but it might be some drawback of MP range on 70 system. The next slide is a high resolution intracranial 4D flow. So this slide includes our technology in development. So we provide a 4D flow acquisition in our product application. And now we are working on some reconstruction techniques to generate the phase contrast MRA and also the cine velocity mapping shown here. So this is a relatively high resolution 4D flow imaging on 70, and as you can see on the left side, we can obtain the high resolution phase contrast MRA images from the 4D flow data. And also the right side, so you can see the cine flow in the intracranial vessels, so which might be useful for the pulsatility evaluation in the intracranial arteries. Yes, that's all for my presentation. I'd like to summarize about main topics. I presented the Airicon DL, Sonic DL, and also vascular imaging at ultra high field. Thank you for your attention.